This lecture is going to be about stoichiometry, empirical formulas, molecular formulas, and all the math associated with it. I've abbreviated this from the slides to focus on the math. We're really not going to go through all the definitions. So when we talk about molecular formulas and using atomic masses to figure out molecular formulas and formula masses, basically all we're doing is we're focusing on the masses you find on the periodic table, and we refer to those masses on the periodic table as the mass, and we're going to start talking about it in terms of grams per mole. Remember last time we lectured, we talked about atomic mass units, and that would be the only chapter we talked about atomic mass units found on the periodic table. However, now we're going to change that atomic mass unit to be in terms of grams. So if I'm talking about the molecular mass of water, what I'm talking about is finding the atomic mass of hydrogen, and there are two of them. I can tell that right from the formula. Added to the atomic mass of oxygen, and there's only one of them. There's no subscript on the oxygen, therefore it's an understood one. And I find these numbers right here and right here. This is an approximation right from the periodic table. So if you look at your periodic table, you will see that oxygen is 15.9954. Rounded up to 16 by many periodic tables. And then hydrogen is 1.008, and there are two of them. So if I add these together, this is the atomic mass, but we're no longer going to say atomic mass units. We're going to call it grams. So when we have an ionic compound that does not have a molecular mass, it has what we call a formula mass. What that means by that is that each formula has its own set of subscripts, even though it can be based in a smaller whole number ratio. That is the empirical formula. So for example, if I'm talking about CH being the empirical formula, I could have three different compounds that are perhaps maybe C2H2, C6H6, and I don't know, maybe C10H10. Okay, these three formulas will be based in the smallest whole number ratio empirical formula, and by way of their multiplied ratios, they become three completely different compounds that have different structures, different physical and chemical properties, and behave differently. So for example, this one right here would have an exceptionally low boiling point compared to this one right here, but they all have the same parent of a 1-to-1 carbon to hydrogen ratio. So if you look at these, you need to be able to calculate the molar mass of each of the formula. So I'm going to do the first one, and I want you guys to go ahead and pause and practice the second two. The first one, propane, can be found by simply taking the mass of carbon, multiplying it by 3, because in the formula it tells us there are 3 carbons. Then you're going to take the mass right from the periodic table of hydrogen, multiplying it by its subscript, which is 8, because that's how many are present. So propane looks like this. There are 3 carbons and 8 hydrogens. Therefore, I have to account for the mass of each thing present. That's why I'm adding up the mass of 8 hydrogens and adding it to the mass of 3 carbons to give me a molar mass of 44.09 grams. For part B, this is your answer. Part C, same thing. Again, we're no longer in AMUs, atomic mass units. We are now exclusively in grams. So if I want to figure out the percent composition by mass of something, we have to consider a few things. You guys have done percent composition your whole life. You just call it something different. If I tell you that I have a pizza and I say, okay, here's my pizza pie, and Sally goes ahead and eats 2 slices, what is the percent of the pizza she ate? Well, we would normally say 2 out of 8 is what she ate. And then, of course, multiply that by 100, and we're going to find that that is 25%. Okay, now we can't do it this way anymore. It's not enough to just say, oh, it's how many per the total number. We cannot say the mass of lithium here is 2 out of 6, where we'd have 1, 2, 3, 4, 5, 6 things. We can't do that anymore, because in chemistry, what matters is mass. So what we actually have to do is find the mass of the entire thing, which is done here. So the mass of lithium carbonate is 73.89, found by taking the mass of 2 lithium, the mass of 1 carbon, and the mass of 3 oxygens, and adding them together. Now what we have to do is say, what percent by mass is lithium? So there are 2 lithiums for every 1 lithium carbonate. So we're simply going to take the mass of 2 lithiums and divide it by the mass of lithium carbonate. Okay, that's going to give us some number, and we're going to multiply this by 100% and get our percent lithium by mass, no longer by number of things. So here you can see the percent lithium is 2 times its atomic mass unit divided by the total mass, and we're going to get 18.79. We could find percent by mass of the carbon doing the same thing. There is 1 carbon, so the mass of carbon divided by the mass of lithium carbonate times 100% is 16.25. And then the mass of the oxygens, doing it the exact same way.